This is for question 4 of your moles book and looking at the empirical formula and moles. And once scientists are able to calculate the number of particles by using the idea of moles in compounds, they can start figuring out the actual formula, the empirical formula of compounds by figuring out how many atoms of each type of particle there were in there. So as it says there, the ability to calculate the number of particles or moles from mass measurements allow the empirical or ratio formula of many compounds to be determined by gravimetric measurements, which means weighing things. Gravimetric means weighing. And therefore, if you know the empirical ratio, you can find the percentage composition of metals in minerals, which is important for, say, extracting metals and determining whether it's worthwhile to mine a certain ore, for example. So when I say the empirical or ratio formula, what it means is the empirical formula is the ratio of atoms in a compound, and because a mole is just a certain number of atoms, if we know the mole ratio, that means we also know the number of atoms ratio, or the ratio of atoms. So using moles, we can calculate these empirical formulae. And then you've got example 4, and it says that 55 grams of titanium reacted in oxygen to form 91.77 grams of a compound. So basically they're burning titanium and making a new compound. And the questions you've got to answer are, what's the mass of oxygen that reacted, how many moles of titanium are in the compound, how many moles of oxygen in the compound, and therefore calculate the ratio of titanium to oxygen to figure out the empirical formula. So let's do that step by step, and each of the colours represents a different part of the question. So first of all, why does the compound weigh more than the original titanium? I had 55 grams of titanium, I burned it, and now it weighs even more. Well, the reason why it weighs more is because it's reacted with oxygen, and now the oxygen atoms are attached to the titanium atoms to make a new titanium oxide compound. So that's why it weighs more. It's got the mass of oxygen attached. And that's handy because the difference in mass, therefore, must be the mass of the oxygen. So the difference in mass between the compound and the original titanium is the mass of the oxygen. And so we can figure out the mass of oxygen that must be in this compound is the mass of the titanium oxide, take away the mass of the original titanium, which is 91.77, take away 55, which means there must be 36.77 grams of oxygen in this compound that we formed. So for part B, how many moles of titanium are there in the compound? Well, once again, write down your equation. Number of moles equals mass of molar mass. What I know and don't know? Well, to figure out this equation, I've got to know the moles of titanium, the mass of titanium, and or the molar mass of titanium. And from the question, we've been asked to find the number of moles of titanium. We've been given the mass of titanium, which is 55 grams, and from the periodic table we can figure out the molar mass of titanium, which is 47.87 grams per mole. So now we can start substituting. The moles of titanium, therefore, must be the 55 grams divided by the 47.87 grams per mole molar mass, which tells me that in this particular compound there is 1.149 moles of titanium. Now, your calculator might have many more decimal places than that, and it's very important in chemical calculations you don't round off in your calculator. You need to be able to store that number in your calculator in one of your calculator's memories. I usually store this number as A, and I write A in my sheet so I know I'm storing this in memory A. If you don't know how to store things in the memory of your calculator, you need to know. It's a critical thing to do when you're doing your chemical calculations. But at this stage, we know how many moles of titanium there are in our compound. The next thing asked us is how many moles of oxygen are in the compound. Now this is one of the times we don't use O2 as our oxygen formula, because once oxygen's reacted in the compound, it's no longer oxygen molecules. They're actually oxygen atoms bound to the titanium atoms. So when we're talking about oxygen, we don't mean oxygen molecules, we mean oxygen atoms, because it's the oxygen atoms in the compound we're talking about. And therefore, once again, we write our equation down. Number of moles equals mass of a molar mass. How many moles of oxygen? What's the mass of oxygen? What's the molar mass of oxygen? Well, looking at my data, I know I've got to find the moles of oxygen. From part A, I figured out there was 36.77 grams of oxygen in this particular compound. And from the periodic table, I know the molar mass of oxygen. Don't forget this is oxygen atoms, not oxygen molecules. The molar mass of oxygen atoms is 16 grams per mole. So now I can go ahead and substitute. Number of moles of oxygen in my compound must be 36.77 divided by 16, which gives me 2.298. I'm sure there's more decimal places there, but it doesn't matter. I'm not going to round off. I'm going to store that in my calculator as B. So now I'm going to have something in memory A, which is the moles of titanium, and something in memory B, which is moles of oxygen. Which leads us to the last part of this question. Calculate the ratio of titanium to oxygen in the compound, and hence the empirical formula. So what I can do here, so let's do that calculation. So we want to find the empirical formula, so we need to find the ratio of number of atoms of titanium to number of atoms of oxygen, which is the empirical formula. Or, because moles is just a way of counting numbers, if we find the ratio of moles of titanium to moles of oxygen, that's the same as the atom ratio. So to find the empirical formula, we've just got to find the mole ratio. Well, what does that mean, the mole ratio? Well, we know the moles of each one. We know the moles of titanium is 1.149. We know the moles of oxygen is 2.298, or more correctly, A to B, the ratio A to B, because those numbers are stored in our calculator. And Well, that doesn't look like a chemical formula. You would never see a chemical formula that says titanium 1.149, oxygen 2.298. We know we use simple whole number ratios in our chemical formulae, so we've got to convert that to a simple whole number ratio. And I'm sure your calculator can do that by itself, but if you don't know how to do that in your calculator, one way you can do it is divide by the smallest number. So what we're going to do is choose the smallest number out of these 2 moles, which is obviously titanium 1.149, and divide both by that smallest number. So we get 1.149 divided by 1.149, 2.298 divided by 1.149. We divide both by that smallest number. That gives us a nice ratio of 1 to 2, which means that 1.149 to 2.298, that's the same ratio as 1 to 2, which means that there is 1 titanium atom for every 2 oxygen atoms, or 1 titanium mole for every 2 oxygen moles. And if that's the case, the empirical formula for this particular compound must be TiO2. So we've got 1 titanium atom for every 2 oxygen atoms, and that's how they figured out the chemical formula of a range of compounds by doing these gravimetric style analyses.